Young friends, welcome to this physics class. In your day-to-day activities, you encounter nature in its colorful attires and great diversity. Physics as a subject is the study of nature and the laws governing it. The laws of nature as studied in physics are real laws. These laws are as revealed to us by nature. These laws are discovered, not man-made. In this series of lectures on physics, we start with the first topic. First topic is force as an effort. Let us start by defining force. Definition of force. Force is defined as it is a push or a pull that changes or tends to change the state of rest or of uniform motion. Here, what is push? Push is the force applied that is directed away from us. We push something away from us. Pull. Pull is the force that is directed towards us. We pull something towards us. Now, next thing is this push or pull changes. That means it is successful to change or has a tendency. It tends to change. It may not be successful. The state of rest and state of uniform motion. The force is something that changes or has a tendency to change the states of rest and of uniform motion. Examples are, we can demonstrate these things by using this diagram. Here we have a ball that is at rest. We kick it, it starts moving. So, it changes the state of rest. Here we have a small ball, we push it, it starts moving from rest. So, the force is successful to change the state of rest. If we have a bigger object, then the force may not be able to change the state of rest or state of motion. Here we have a truck, a bigger object. Truck is stationary at rest. We push it from behind to try to move it, but we are not, in general, we are not successful. Here we have a truck that is already running. We pull it from behind or we may push it from front, it may not stop in general. So, when objects are bigger, force efforts to change the state of rest or state of motion, it may not be successful. So, force is a push or a pull that changes or may try to change the state of rest or of uniform motion. Now, here we have rest and uniform motion. In physics, all these terms, rest, motion, uniform motion, have their precise meaning, precise definitions. Before proceeding to elaborate more about force, we will first define what is rest, what is uniform motion, and other terms related to motion. First, we have rest. It is the state of a body when its position with respect to its surroundings does not change. That is, body is fixed. The position or the distance of the body from its surroundings remains unchanged. Examples are a tree, building, car or truck in a garage, we have these objects lying on the table at rest. Their position with respect to other things lying on the table is unchanged. So, these things are at rest. Now, if the position of something with respect to its surrounding is changing, that the body is not at rest, we call the body is in motion. We define motion motion is the state of a body when its position with respect to or relative to its surroundings is changing. Examples are running, cars, buses, trains, aeroplane in flight, wind, air in motion, water in rivers, canals, etc. Now, the question arises, when we talk about something at rest, something in motion, whether this state of rest or state of motion is absolute or something which we say is at rest, can we call it to be moving with respect to some other surroundings? We can form a question: are rest and motion absolute, or this could be are rest and motion relative. Now, we can take some examples. We have passengers in a compartment of a running train. These passengers are at rest with respect to each other. They can play cards, they can play other games as they were sitting in their rooms. Now, they are at rest with respect to each other. Now, what about relative to an observer at the station? Are they at rest with respect to the observer at the station also? No, the train is running relative to the station. So, that means the passengers and the train are in motion relative to this observer. Similarly, this observer in motion in the opposite direction to these passengers and the train. Another example is, there is a class, students are sitting in the class, they are at rest relative to each other, relative to the desks in the room, relative to the board in the room. Now, there is an aeroplane. Aeroplane is running, flying above their class. Now, are these students at rest relative to the passengers, air travelers? No, they are moving in the direction opposite to the direction of flight of the plane. So, rest and motion are not absolute, rest and motion are relative. Rest and motion are not absolute, rest and motion are relative. An object or a body can be at rest or in motion at the same time, simultaneously. At the same time. So, the same body that is at rest with respect to something may be in motion with relative to something else. Now, when we are talking about motion, motion can be in a straight line, motion can be on a plane, motion can be in space. So, we have three kinds of motion. Number one is motion in a straight line, this is also called one-dimensional motion. One-dimensional or 1D motion. If a body moving in a straight line is said to be in one-dimensional motion. Examples: a train on a straight track a car on a straight road, a bead moving in a straight wire, a body falling freely, these are some examples of one-dimensional motion. We have here some examples of this motion. One-dimensional motion, why it is called one-dimensional motion is because we need only one coordinate or one axis is required to completely define the body. Suppose we have a straight line motion. In the straight line motion, the object, the body is moving along the straight line. So, if we know its position along the x axis, then the position of the body is fully defined. We can say at a time t, the body is at a distance x from O along x axis. So, if we know its x coordinate, we know its motion completely. Similarly, if a body is falling freely, we can have, if we know this coordinate, let us call y axis, this is y axis. If we know the position of the object A at different times relative to this point O, then along the y axis, then we can say we know the motion of the object completely. Similarly, we can have a spring if we suspend a load with a spring and pull it downwards and leave, then this vertical motion of the load is also one-dimensional motion. We can take this vertical axis as x or y axis. Here we have some models. On the basis of these models, we can show what kind of motion these objects have for one-dimensional motion. Here we have a bead. This is a straight wire. In the straight wire, this bead is moving. Then this motion is one-dimensional motion. When the object is falling down, it is, or moving up, it is a one dimensional motion. Even if the wire is tilted to the vertical, even then it is a one dimensional motion. Here we have a track. If a ball is moving on the track, then this motion is one dimensional motion. This motion of the ball on the track is one dimensional motion. This track may be horizontal, may be tilted to the horizontal. In both the cases, this motion is one dimensional motion. Here we have a plane. Plane moves in a straight line. This motion is one dimensional motion. Motion of the plane is a one dimensional motion as it moves in a straight line. Now, if the object, instead of moving along a straight line, it moves on the plane, like I write on the board, the tip of the pen is moving on the plane of the board. To fully define this motion, we need two coordinates. So, this kind of motion is called two dimensional motion, motion in a plane. Or two dimensional motion. When a body is moving in a plane, then its motion is called two dimensional motion. For two dimensional motion, we have, when I write on the board, position of the tip can be defined by two coordinates. Let us call this x axis, this is y axis, this is origin. Point P is on the path that we have followed. Distance from the y axis is x coordinate, distance from x axis is y coordinate. So, we have x and y coordinates of point P. So, to fully define the motion on the motion of the tip of the pen on the board, we need two coordinates. Now, if we have these two coordinates, then we will call this type of motion as two dimensional motion. Now, suppose we have another example, a projectile. Projectile is, if we have, say we have a cliff, we throw the ball, this ball moves like this. So, we need x coordinate, y coordinate and x coordinate. This is origin and x axis, y axis. So, we need two coordinates. So, this kind of motion also is a two dimensional motion. If we have a boat in a tub, this is, and it is moving in the tub at the surface of the tub, this is a two dimensional motion. Now, if instead of a boat we have a submarine, instead of a boat we have a submarine, this motion is called three-dimensional motion. Three-D motion is motion in space. In this case, we have this kind of motion we define as when the object moves in space, that is, its motion is completely defined with three coordinates x, y, z coordinates. Examples: a kite, aeroplane, submarine, we can show this motion, 3D motion, by using the models. Here we have a spring. As this bead moves along this helical spring, it is moving in 3D. Its motion is up and down, forward or backward, left and right. So, we need 3 axes. So, this kind of motion is 3D motion. If we have this plane, we throw this plane, toy plane will move in space. It is moving, it is circulating around, and it is moving up or down. So, this is a 3D motion. Now, when we have discussed all the 3 kinds of motion and we want to go into details, we want to elaborate motion, we make some simplifications. Simplifications are: number 1, we consider the body's motion only in one dimensional. So, we consider the body to be moving along a straight line. This we can do because 2D and 3D motions can be discussed by taking them as combination of two or three independent 1D motions. Another simplification that we will make in our later discussions is the body. Body has its length, its breadth, its diameter, its radius, its height. We do not go into the details of the body, rather we consider it as a point particle. Instead of considering a car or a bus or a truck in motion, we will consider them only a point to be moving. In today's lecture, we have discussed terms like force, rest and motion. In the coming lecture of the series, we will be discussing terms related to motion, terms like displacement, speed and velocity, etc. Thank you.